question number 1. Let the predictor variable X represent heights of males, and let the response variable Y represent weights of males. A sample of 153 heights and weights result in the standard error equals 16.39668 centimeters. Using the regression found in the data, a height of 175 centimeters is used to find that the predicted weight is 91.3 kilograms, and the 95% prediction interval is 58.8 kilograms to 123.8 kilograms. First, write a statement that interprets the prediction interval. Choose the correct answer below. We have 90% confidence that the limits that they're giving us contain the value of the weight for a male with a height of 175 centimeters. We have 95% confidence that the limits contain the mean. No, we're looking for individual values, not the mean. Anything that says the mean would not be true for prediction interval. There is a 95% probability that these limits contain the mean. No. And there is a 95% probability that the limits contain the value of the weight for a male with a height of 175 centimeters. Whenever we're looking for the prediction, we have a 95% confidence that our prediction contains the value of the weight of a male. Check answer. What is the major advantage of a prediction interval instead of simply using the predicted weight of 91.3 kilograms? The advantage of a prediction interval is that it gives a range of weights that contains the true value as opposed to the predicted weight, which is an estimate of the true value and may or may not be accurate. There is no advantage. There is an advantage. We won't even look at that. The advantage of using a prediction interval is that it gives a range of likely weights instead of a single value, but not as large of a range as the confidence interval. The prediction is more accurate. That's opposite of the truth. The prediction interval is always bigger than the confidence interval. That is not true. The advantage of using a prediction interval is that it gives a range of likely weights, so we have a sense of how accurate the predicted weight is likely to be. I like that the best. Perfect. Why is the terminology of prediction interval used instead of confidence interval? A prediction interval and a confidence interval are identical. Again, not true. A prediction interval is used for an interval estimate of a variable, whereas a confidence interval is used for an interval estimate of a population parameter. That's true. A prediction interval is used for an interval estimate of a population parameter. No. A prediction interval and a confidence interval are identical. No. That is the correct answer. Let's check our answer. Assume that you have paired values consisting of height in inches and weight in pounds from 40 randomly selected men. The linear correlation coefficient R is 0.574. Find the value of the coefficient of determination. What practical information does the coefficient of determination provide? We need to take R, which is 0.574, and square it, but I don't see a square. We'll just multiply it by itself. This is my coefficient of determination. We know it's not the first two, it's one of the second two. 67.1% of the variation is explained by the linear correlation, and 32.9% is explained by other factors. That's opposite. The coefficient of determination is what explains the linear correlation. I multiply by 100, and that is my percentage. 32.9% of the variation is explained by the linear correlation, and 67.1% is explained by other factors. Use the accompanied paired data consisting of registered boats in tens of thousands and manatee fatalities from boat encounters. Let X represent the number of registered boats and let Y represent the corresponding number of manatee deaths. Use the given number of registered boats and the given confidence level to construct a prediction interval estimate of manatee deaths. Use X equals 81, which is the same as 810,000 registered boats with a 99% confidence level. They're giving us data. We're going to open this data in StatCrunch. Here's my boats and my manatee. Go to Stat, Regression, Simple Linear. My X is boats, my Y is manatee, and my prediction of Y. I put X equals 81. I have a 99% confidence interval. I need to change this level to 99% or 0.99 and compute. Find the indicated prediction interval, round to 3 decimal places. If I round this to 3 decimal places, this becomes an 8, and this should be our prediction interval. Listed below are altitudes in thousands of feet and outside air temperature in degrees Fahrenheit recording during a flight. Find the explained variation. Open StatCrunch. Go to Stat, Regression, Simple Linear, hit Compute. Find the explained variation, analysis of variance table for regression model. For our model, this means sum of squares, and this is our explained variation to 2 decimal. Find the unexplained variation. We go back here, and that's my error right here. And they want that to 5 decimal places. 1, 2, 3, 4, 5. The next number is a 4. I don't have to read up. And that would be my unexplained variation. Find the indicated prediction interval. Use 95% confidence level and the altitude of 6,327 or 6.327 thousand feet because the altitude is in thousands of feet. We go back here to edit, and we don't need to edit any of that. We need to put in here 6.327. We are at 95%. Hit compute. Go down to the bottom, and there's our prediction interval, round to 4 decimal places. 1, 2, 3, 4. That's going to round up to a 6. Check answer. And there we have it. If you have any questions, please let me know. Thank you very much.